Okay folks, this is a video for the tangent and cotangent graphing worksheet. Just 4 problems here. This is the first one. So, problem numero uno. As always, let's go ahead and factor the inside. So let's pull out that -2. What are we left with? Well, we're left with x plus, how do we pull a 2 out of a pi over 2? Well, that's saying, what's pi over 2 divided by 2? Well, that's pi over 4. And so we have x plus pi over 4 there. Check it, if you threw that -2 back in, you'd get -2 pi over 4, which would simplify to -pi over 2. Okay, so that's that, and we have the negative tangent. But again, remember that tangent is an odd function, which means that we could pull that negative out front, which would give us a double negative, making this equivalent to tangent of positive 2 times x plus pi over 4. So what's our period? Well, our period is normally pi for a tangent function, but we're dividing it by that coefficient of 2, so our period is going to be pi over 2. So now I can sketch this in. I'm going to label one full period right there at pi over 2. I'm going to label the halfway point at pi over 4. I'm going to give myself another tick mark over here for 3 pi over 4. We're shifting it to the left, so I'm going to give myself one additional tick mark right here at -pi over 4 as well. Well, think about the tangent function. Tangent is sine over cosine. Sine's first value is 0, which means tangent's first value is 0. So I need to start at -pi over 4, and I need to be 0. One full period later, I should be back at 0, so that means after going pi over 2 to the right, I should have another 0. So at this pi over 4 right here, I should have another 0. And I could even do another full period to the right and put another 0 right there. And then what happens in between? Well, in between I'm going to get my asymptotes. So there, there. Think about the asymptotes are coming from when cosine is 0. Cosine is 0 at pi over 2, so move to the left, pi over 2. Move to the left from... Sorry, I choked on my words there. If you think about these values, again, a full period happens in just the first half of the unit circle. So normally sine is 0, our first point. That's been shifted to the left by pi over 4. Normally our first cosine value, where we are 0, would be happening at pi over 2, but since we are multiplying that by 2, all we need to do is put in a value of pi over 4, and then when we multiply that by 2, we get pi over 2. And so really that means our first asymptote, where cosine is 0, will happen at 0, because it would happen at pi over 4, but we're shifting everything to the left by pi over 4. That's a really complicated way of saying what I'm saying. My cosine graph is going to look like this, going up like that, and then coming back up there. That's technically 2 full periods of it. The idea I want you to really take with you is that the period of cosine right there normally is pi. This time it's pi over 2, but the point is that when you're dealing with this, half the period should be halfway through your full function. So half of a full period is going to correspond to one full section of either positive or negative leg of that tangent graph. Okay, second graph here, y equals -2 tangent x over 3 minus pi over 6 plus 3. Okay, so again, let's factor the inside. That's always how we start. We'll factor out that 1/3, and we'll be left with x minus, if you pull a 1/3 out of a 1/6, what did you do? Well, we took 1/6 and divided it by 1/3, which is to say we multiplied it by 3, so we get 3 over 6, which is 1/2. So we get x minus pi over 2. Close that off. We're still adding 3 to it, and it's still a -2 tangent function. Okay, then, well, let's take this piece by piece. Let's draw our axes. First off, I am going to shift everything up by 3 and give myself a little axis of symmetry right there. I'm going to then determine that my period is going to be the normal pi, but it's going to be divided by the coefficient of 1/3, which means pi divided by 1/3 is the same as 3 pi, just right there like that. And so, this one's going to be a little goofy, a little tricky, but we can do it. So full period is 3 pi. So I'm going to label this right here as 3 pi. Let's split it in half and label this 3 pi over 2. Because then now I have my halfway point for my full period, but we're shifting everything to the right by pi over 2. So if that's 3 pi over 2, we can split that up into 3 equal pieces to give me a pi over 2 right there. And then we can split that one up as well. So again, I'll give myself big tick marks and smaller tick marks because everything is going to be going to the right by pi over 2. Okay, well, what else do we know? We know that this is a negative tangent graph, which means it's going to go down first. So let's start graphing what we know. We know the first point of the tangent graph is 0. So at pi over 2, I should have a 0, but it's not a 0 because it's shifted up by 3, so I should be on that axis of symmetry. So right there, I should have a 0. One full period later, which in this case is 3 pi, so if I go one tick mark to the right of 3 pi, I should get another 0. And then in between there, I should get an asymptote. So I'm going to get that right there. We said that because this is a negative tangent graph, I need to be going down first. So this graph needs to come down like that. And then this part would have to come down like that. And that will be one full period of this graph. But the instructions are to graph at least 2 full periods. So I need to extend some things out a little bit. So let's give myself another pi over 2. No, what do we want? Another 3 pi over 2 in the other direction. So let's go label this negative 3 pi over 2. Because then one tick mark to the right of that should be another asymptote. And what is that tick mark right there? Well, that should be negative pi right there. But I should be able to sketch in that asymptote and then sketch this graph going up like that. And okay, really break it down into what it is. Look at the little tick marks, make sure we have good symmetry. From here, if I go 1, 2, 3, I hit my halfway point, and I go 1, 2, 3, I hit my full period right there. It's a length of 3 pi. It's a long one, but it's there. We're good. Okay, well, let's finish this off over here. What do we need to add to this side? Well, if we have 6 pi over 2 there, then we should also get a 9 pi over 2 right there. And we can split that in half as well. My marks aren't very evenly split, but you get the idea. Now I need to be 1 to the right of this. So I need to have a little tick mark right there. And then I can dash in that asymptote. Boop, boop. And then this can come down like that. And now that should represent 2 full periods of this graph. Alright, let's graph a cotangent graph now. Again, we need to figure out what the period is going to be. So we're going to take the normal period of pi and divide it by the coefficient. So we're going to get a period of pi over 4. And we're shifting everything down by 3. So let's draw some axes. And let's go 1, 2, 3, and let's dash in a line of symmetry. Okay, well, where does cotangent start? Well, cotangent is cosine over sine, and cosine starts at 0, which means that I'm a liar, because cosine starts at 1. So we get 1 divided by sine of 0. Sine of 0 is 0, so we have 0 in the denominator, which means our first point is actually going to be that vertical asymptote. So let's figure this out now. I'm going to label this as pi over 4. I don't have any phase shift, which is nice for once. Let's cut this in half and call it pi over 8. And now let's think about what we know. We said we're going to have a vertical asymptote at our starting point, which means we'll have another vertical asymptote a period later, which is pi over 4. Okay, those got crooked. How about we go those straight down there? Okay, what else do we know? Well, we know in between there we will have a 0. So at pi over 8, we need to have a 0. And cotangent needs to start out positive because all of the functions start out positive. So my graph needs to come down and look like that. Ba-dum, boom, boom. That was not difficult at all. And so now let's do another period. So let's label this distance, instead of pi over 4, we'll call it pi over 2. And we'll call this 3 pi over 8. And then it's going to follow the same exact pattern. It's going to start up and it's going to come down like that. And so we should have another asymptote right there at pi over 2. And we're done! That was quick, and actually I put my 0 in the wrong spot, so we're not done. Because that should be right there. And now I'm using the wrong color, so that should be right there. And then we'll get that asymptote in. No, that's the wrong color. Now we'll get that asymptote in. Boop, boop, boop. And so we should now be able to sketch that in and be good. And there you have it. It's a little ugly, but that's it. Alright, and finally problem number 4, cotangent of negative x over 8 plus pi over 3. So let's factor out that negative 1/8. And what are we left with? We're left with x minus something. What's that something? Well, let's take pi over 3 and divide it by 1/8, which is the same as multiplying it by 8. Right? Pi over 3 divided by 1 negative, why won't it write? It's not writing. Negative 1 over 8 is the same as pi over 3 times negative 8. I mean, technically over 1. But, so we get negative 8/3 as our period, which honestly kind of sucks and is pretty ugly, but we can still do it. It's not the end of the world. I might have said as our period. Shouldn't be as our period, but we get negative 8/3 as our phase shift right there. Okay, so then what is our period? Well, our period is normally pi, but we are dividing it by 1/8, which means our period is 8 pi. Yikes, that's nuts. It's really long. Okay, well, what more can we do? Notice I forgot my pi. That should be negative 8 pi over 3, and that should be negative 8 pi over 3 for that phase shift there. Okay, well, what else do I know? I have that negative in my cotangent function. Well, cotangent and tangent are both odd functions, which means that we can pull the negative out front. So I can rewrite this as negative cotan. Cotan of 1/8 times x minus 8 pi over 3. Okay, so let's now start working with this ugly mug. Split it up. Normal period, well, not normal period, but modified period now is 8 pi. And we need to split that up into 8 pi over 3. Yikes, gross. First thing I'm going to do is I'm going to split this in half and call that 4 pi. Okay? Alright, next thing I'm going to do is I'm going to figure out where does 8 pi over 3 fit into the mix now. Well, what I'm going to do is I'm going to split everything up into thirds. If I, again, give myself some big tick marks there, if I split this into thirds, I'm getting 4 pi over 3. So that's 4 pi over 3, which means that the next one is 8 pi over 3. And then I'll split these up as well, like that. And let's start and see what we can do. Well, cotangent, again, starts with an asymptote. So I need to have an asymptote at positive 8 pi over 3. So there's my first asymptote. And one full period away, I need to have an additional asymptote. So I'm going to extend these axes out to the right. I'm going to draw that a little more straight, a little less crooked. There we go. And let's say then one full period is normally 8 pi, but I'm going to continue to split this up, call that 12 pi. One period's normally 8 pi, except this has been shifted to the right by 2 small tick marks, so my period will end there, like that. Okay. Now, what do we know? We know halfway between we should normally get a 0, but again, this time everything's shifted over 2 tick marks to the right, so halfway between my asymptotes is right there. And now I can sketch it in. Cotangent normally starts out positive, as do all functions, but we pulled that negative out front, so I need to start negative. So this graph needs to come up like that, and cross, and then go up, like that. And there we have one period. Let's draw one more. Let's go to the left just for fun and just because we can. So I'm going to extend these out. I'll label this as negative 4 pi. And then split these tick marks up again, just like we've already done. Because now I need to label a little bit more. Put 2 small tick marks there. And what can I do? One full period away, I should be back to where I started. So if this was a full negative 8 pi, normally I would have another asymptote there, but everything is 2 tick marks to the right, so I need to have my asymptote right there. Boop, 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 boop. And now that should be one full period, which means I should have another 0 right there, halfway between. Notice that it's 1, 2, 3 tick marks, 1, 2, 3 tick marks in both directions to get to the asymptote. And now I'll just sketch in that same shape, like that. And I am happy hunky-dory. There are my 2 periods, my 2 cycles.